Welcome to today's class. So we'll continue from torsion in strength of materials. So let's consider we have the problem on the board, and it says calculate the size of a shaft which will transmit 40 kilowatt at 2 revolutions per minute. The shear stress is not to exceed 50 meganewtons per meter squared, and the twist is limited to 1 degrees for each 2-meter length of the shaft. Take the shear modulus of rigidity G as simply 77 giganewtons per meter squared. Alright, so let's get down the parameters that was given to us. Well, we're given power. Okay, power transmitted should not be should not exceed 40 kilowatts. So power was given to us. Power P equals 40 kilowatts. We were also given the speed of revolution N. Okay, speed N was given simply as 2 revolutions per minute. So we simply have 2 RPM. Okay, they said the shear stress should not exceed 50 meganewtons per meter squared. So we have the shear stress. Okay, tau equals 50 meganewtons per meter squared, and of course we may wish to convert that. So this simply implies that the shear stress is actually 50 by 10 to the power of 6 newtons per meter squared. That becomes the shear stress for the shaft material. Okay, we are also given the angle of twist. Angle of twist was given as 1 degrees. Okay, so angle of twist. Okay, theta was given as 1 degrees, and of course you know that we always have to convert the angle of twist to be in radians. So converting theta to be in radians, theta is simply equal to 2 pi in radians. The angle of twist 1 degrees is equivalent to 2 pi in radians. Okay, so should in case you have more than 1 degrees, let's say you have up to 2 degrees or 3 degrees, all you need to do is simply multiply that value by what? 2 pi. If it's 2 degrees, it becomes 2 times 2 pi, which actually gives us 4 pi in radians. If it is 3, it becomes 3 times 2, which actually gives us 6 pi in radians. So that's the angle of twist in radians. Okay, so we're also given length. The length was given, length L was given simply as 2 meters, and we were given the shear modulus of rigidity, which is simply G, as 77 giganewtons per meter squared. So we can simply convert this to be 77 by 10 to the power of 9 newtons per meter squared. So this becomes the value of the modulus of rigidity. So if you have this, the question is asking us to find the size of the shaft. When they say size actually means the diameter of the shaft. That's what the question is asking us to find. Simply the diameter of the shaft. Okay, diameter is unknown, so you can put that down. Diameter D is actually unknown, so you have this. Now let's recall from our torsion equation. Recall that we have T all over J equals G theta all over L equals shear stress all over radius. So this gives us the torsion equation. So all we need to do now is simply look at this equation and look at the given conditions. Anyone that satisfies any two of this equation, that's where we work from. We have G, which is the modulus of rigidity, was given to us. We also have the angle of twist, which is theta, it was given to us. We have the length, so automatically it means we are going to use this middle one. And then so we need to look for what? An equation which you can use to relate any of them. So you have the shear stress, and of course if you have the shear stress and the radius, it means you can actually find the diameter of the shaft. So we can actually work with these two, or you can as well work with this. Okay, when given the torque, so which means we cannot work with this, so we can simply work with these two part of the equation. Okay, so using G theta all over L equals shear stress all over R. Okay, so we know G, we know theta, we know L. we know the shear stress. Let's simply make radius subject of the formula. If we make r subject, this simply implies that r becomes simply cross multiply length multiplies by the shear stress, then divide through by g theta. We are simply going to have L times the shear stress all over g theta. So this simply gives us the value for the radius. Okay, so r is now equal to length was given as 2 meters. From the question, we have the length to be 2 meters, simply 2 multiplied by the shear stress was given as 50 meganewtons, which is simply 50 by 10 to the power of 6. So you have 50 by 10 to the power of 6 all over the shear modulus of rigidity G, 77 by 10 to the power of 9. You have here 77 by 10 to the power of 9 multiplied by the angle of twist theta, which is simply 2 pi in radians. So multiply by 2 pi. Okay, so r equals 2 by 50 by 10 to the power of 6 simply gives us 10 by 10 to the power of 7 all over. You have here now 77 by 10 to the power of 9 multiplies by 2 multiplies, of course, pi is simply 3.142 multiplies 3.142. So you simply have this. Alright, so we have the radius r to now be equal to 10 by 10 to the power of 7 all over, please give me 77 by 2 by 3.142. So you have 483.87 multiplied by 10 to the power of 9. Okay, so this simply implies that r is equal to, so do 10 by 10 to the power of 7 divides 483.87 exponential 9. So the radius is actually 2.07 in meters. This becomes the radius of the shaft. Now, in order to find the diameter of the shaft, diameter d, okay, diameter d is actually 2 times radius. The diameter of the shaft is simply 2 times the radius. So this simply means that d is actually 2 times 2.07, and that implies that diameter is actually 4.14 in meters. So that becomes the size of the shaft. So that's how you calculate the size of the shaft using the torsion equation. Okay, so also taking a look at the torsion equation, we can as well choose to use these two to solve, but going through this route is quite tedious, but you will still obtain the same results because from the equation we are given power, and you know that power P is actually 2 pi nt all over 60,000. Okay, this is the equation for power. So we are given this equation. So all we need to do is simply make torque subject of the formula. We know the value for n. The speed in revolution was also given. So make torque subject. Then you can use this equation. Not forgetting that J, being the polar moment of inertia, is actually pi d4 all over 32. So you can as well, once you use this relationship, make J the subject of the formula, then find the value for D. But going through this route is quite strenuous, so you choose to go with the easier part, which is this. So that's how you find the diameter of the shaft. All right, guys, thanks.